What if an advanced civilization existed on Earth millions of years before us, and we'd never even know? We tend to think of human civilization as the first and only intelligent species this planet has ever produced. But Earth is 4.5 billion years old. Complex life has existed for over 500 million years. Modern humans have been around for just 300,000, and we've only had technology for about 200. That means 99.99% of Earth's history happened without us. If another civilization rose and fell during that time, would anything be left for us to find? In 2018, NASA scientist Gavin Schmidt and astrophysicist Adam Frank asked this exact question. They called it the Silurian Hypothesis, named after an old Doctor Who species, not actual dinosaurs. And their conclusion was disturbing. Here's the problem. Civilization is surprisingly fragile in the geological record. Our entire industrial era, every building, every road, every machine we've ever built, exists in a layer of sediment thinner than a cigarette paper when compressed over millions of years. Think about what happens to specific materials. Steel, one of our most durable creations, begins rusting immediately when exposed to the elements. A steel skyscraper would collapse within 300 years and be completely oxidized within a few thousand. Glass is more resilient. It can persist for tens of thousands of years, but even glass eventually devitrifies, losing its structure and becoming indistinguishable from natural silicates. Concrete, the backbone of modern infrastructure, begins to chemically break down within 10,000 years as water and carbon dioxide eat away at its calcium compounds. After 100,000 years, even the most massive concrete dam would be reduced to gravel and calcium carbonate, basically limestone. After 1 million years, all that might remain are subtle chemical anomalies in the rock record, strange spikes in carbon isotopes, unusual concentrations of synthetic molecules, tiny traces that could easily be mistaken for natural geological events. After 10 million years, the evidence becomes nearly impossible to distinguish from background noise. After 100 million, forget it. Even our nuclear waste, some of the most persistent material humans have ever created, would have fully decayed. The geological record would have swallowed every trace of us whole. But Schmidt and Frank realize something. We're actually leaving chemical ghosts right now. The Anthropocene, our current era, is producing signals that might be detectable millions of years from now. Massive spikes in carbon-12 from burning fossil fuels, nitrogen anomalies from industrial agriculture, traces of synthetic chemicals that don't exist in nature, things like plasticizers, pesticides, and radioactive isotopes from nuclear testing. And here's what's fascinating. When scientists look back through Earth's geological record, they find events that look eerily similar. Sudden, unexplained changes in the planet's chemistry. The Paleocene-Eocene thermal maximum, 56 million years ago, shows a massive spike in temperature and carbon, remarkably similar to what we're doing to the climate right now. During the PETM, global temperatures surged by 5 to 8 degrees Celsius. Ocean chemistry shifted dramatically. Massive amounts of carbon flooded the atmosphere in a geologically short burst, perhaps over just a few thousand years. The leading explanation is volcanic activity in the North Atlantic, possibly triggering the release of methane from ocean floor deposits. But here's the thing. The rate of carbon release during the PETM was actually slower than what humans are producing today. We are literally outpacing whatever caused one of the most dramatic climate events in the last 100 million years. If a future geologist compared the two events, ours would look more extreme. Could the PETM be the fingerprint of a previous civilization? Probably not, but the uncomfortable truth is, we can't rule it out. with certainty. And that's the whole point. The Silurian hypothesis gets even more interesting when you look beyond Earth. Mars had liquid water, a thick atmosphere, and a magnetic field for its first billion years, conditions potentially suitable for life. If a civilization arose there and collapsed, erosion and radiation would have erased nearly all evidence by now. Mars lost its magnetic field roughly 4 billion years ago when its core cooled and solidified. Without that magnetic shield, the solar wind slowly stripped away its atmosphere over hundreds of millions of years. Any surface evidence of life or civilization would have been bombarded by ultraviolet and cosmic radiation ever since. 4 billion years of that would sterilize the geological record down to considerable depth. Even our most sophisticated rovers might be looking right at the evidence and not recognizing it. Venus is even more intriguing. Recent climate models from NASA's Goddard Institute suggest that Venus may have maintained liquid water oceans and temperate surface conditions, temperatures between 20 and 50 degrees Celsius, for up to 2 billion years. That's longer than complex life has existed on Earth. 2 billion years is an almost incomprehensible window of opportunity. Life on Earth went from single cells to spacefaring civilization in less time than Venus may have been habitable. A Venusian civilization could have risen, thrived, and been completely erased by the planet's transformation. When Venus experienced its runaway greenhouse effect, surface temperatures soared to over 450 degrees Celsius. The entire surface was resurfaced by volcanic activity multiple times over. We wouldn't find a single trace today. It's been essentially pressure-cooked and paved over. And then there's the broader universe. If civilizations routinely rise and fall over cosmic timescales, the galaxy could be littered with dead worlds that once held intelligence. Silent planets orbiting quiet stars, their histories completely erased by time. The Silurian hypothesis isn't really about ancient aliens. It's about a much deeper question. How do we know what we think we know about the past? We assume we'd find evidence of prior civilizations if they existed. But that assumption might be completely wrong. Our ability to detect the past has enormous blind spots, especially as we look further back in time. This matters for the search for extraterrestrial life too. When we look at other planets and see no signs of civilization, we assume nobody's home. But we might just be looking at the ruins. Ruins so old they've become invisible. There's also a warning buried in this idea. If a civilization can rise to our level and then vanish so completely that no trace remains after a few million years, that means the universe doesn't care about preserving our legacy. Everything we build, everything we create, everything we are, on a geological timescale, it's temporary. Consider the comparison. The dinosaurs ruled Earth for 165 million years. They survived asteroid impacts, supervolcano eruptions, and dramatic climate shifts, and still their reign eventually ended. We've had written language for about 5,000 years, agriculture for about 10,000, industrial technology for barely 200. If we disappeared tomorrow, in 10 million years, the only evidence might be a thin layer of plastic particles and a slight carbon anomaly that some future scientist might puzzle over. The dinosaurs had a 165 million year head start on us, and all they left behind were bones and footprints. What makes us think we'll do better? So were there alien civilizations in Earth's past? We genuinely don't know. And that's not a failure of science. It's a feature of time. The universe is very, very good at keeping its secrets. The real question isn't whether lost civilizations existed. It's whether ours will leave a mark that lasts any longer than theirs did.